This is Solo for Math. In today's episode, we're looking at item 9 of our paper, and it goes: the Future Leaders Club analyzes the projected profit margin of a school-based enterprise. The profit margin, Px, as a function of the number of items sold x, is modeled by the rational function given there. So where P is expressed in percentage points. To better understand how the profit margin behaves for different levels of sales, the club was advised to decompose this complex function into simpler, more manageable parts using the method of partial fractions, a process they are not familiar with. So you can already see that our challenge is already there. If you run to the tasks, help the club to part A, decompose the complex function into its partial fractions. Before we even continue, you can easily identify that the challenge we have at hand is being able to decompose the rational function given into simpler functions or simpler parts in order to understand how the profit margin behaves. So if you're responding to part A of the question, so this is our rational function that we need to decompose into partial fractions. So we need to come and study the nature of the denominator given. So if you look at this expression here, the denominator has two factors, of which one of the factors, which is x plus 1, we call it a linear factor, and then this other factor is a repeated factor because it has a power bigger than 1. So if you are to decompose this, realize that it will have three parts. The first part will be due to this. We have a denominator which is a linear with a linear factor, and the numerator will be of the form a over x plus 1 plus the next part will be b over x minus 2. Then the last part will be c over x minus 2 squared. So this is how we handle the linear factor. If it's a linear factor, we simply get an unknown divided by that linear factor. Then for the repeated roots, you go on raising the power of the factor from 1. So we see this is a b, the first part of the repeated root or repeated factor, b over x minus 2, then plus c over x minus 2 squared. Now we need to find the value of a, b, and c, and then we are good to go. So how do you find that? What we do, find the LCM. The LCM of this is normally equal to this, x plus 1 into x minus 2 squared. Now we go on dividing the way we handle fractions. If we divide this by this denominator here, we end up with x minus 2 squared times a, plus if we divide this by this, we end up with a b into x plus 1 into x minus 2. And then if we divide this by this, we remain with plus c into x plus 1. Alright, now if we look at the left hand side and the right hand side, you see that the denominators are the same. We have x plus 1 into x minus 2 squared here, the same this side. So it means that the numerators are also identical because we are relating this with this. If the denominator is the same, then we assume or we suppose the numerators are identical. So it means 11x minus 2 is equivalent to what was the numerator, a into x minus 2 squared plus b into x plus 1 into x minus 2 plus c into x plus 1. Now we need to find the values of a. What you're going to do, you're going to suppose values of x, and I'll start with x equaling to 2. Use values of x that will help you eliminate some parts and you remain with maybe one unknown. For example, if my x is 2, we see that if we substitute on the left hand side, we shall have 22 minus 2 equals 2. This will go because this will be a 2 minus a 2, which is a 0. So it means that all of this goes, and this will also go because we have a 2 minus 2, which is a 0, and it makes all of this 0. So it means we remain with only c, which is equal to into 2 minus 1. So, it's a plus. So it means this is 20 equals to 3c, and therefore our c is 20 over 3. So we've gotten our c. Let's proceed. How best can we get the value of maybe b or a? So I see, since I have x plus 1 here and x plus 1, I can let x to be equal to -1, so that it will help me eliminate this part. It also eliminate this, and I'll remain with only this, and I'll be able to find the value of a. So if x is -1, substitute on the left hand side, you have -11 minus 2 equals 2. So we remain with this, since this and this go. So we remain with a into -1 minus 2 squared, and this is a -13 equals 2. This is a 9a. So it means our a will be equal to -13 over 9. And lastly, how do we find a c? Now for a c, I don't see any letter that can help me, or any number that can help me eliminate any of these parts, to eliminate a and this part with b, so that remain with c. No, sorry. I don't see any number that will help me eliminate c and a, so that remain with only b. So what I will do, I will let my x to be equal to a 0. Just use any simple number. Don't work with big numbers. Choose a 0, because I know with a 0 it will help me reduce on the big values that will be stubborn, so that I remain with simple values. So if my x is 0, you see on the left hand side I remain with -2 equals 2. This will be, if we feed here 0, this will be 4a. And if we feed here a 0, this will be a b times a 1 times -2, which will be -2b minus 2b. And then when we feed here 0, this will be 0 plus 1, which is a 1c, which is a c plus c. Now we already have a, we already have c, so substitute. So we have -2 equals to a 4 times, what was our a? -13 over 9 minus a b, I mean a 2b, since we don't have a b, we leave it. So plus c, which was 20 over 3. Now here, you work with your fraction skills to make sure that you find the value of b. So I can start by multiplying throughout by 9. If you multiply here by 9, this will be -18 equals 2. This will be 4 times -13, which will be a -52. And then this one will be minus 18b plus, this will be, if you multiply this by 9, a 3 will reduce a 9 to remain with a 3, so this will remain a 60. A 3 times 20, which is a 60. On simplifying, we shall remain with 18 bar equals 2. If we bring everything on the other side, we shall remain with 26. And on simplifying, we remain with b equals to 13 over 9. So our b is 13 over 9. So we substitute back in this expression here. So on substituting back, our px will be equal to a -13 over 9 into x plus 1 plus 13 over 9 into x minus 2 plus a 20 over 3 into x minus 2 squared. And we've responded to our part A. We've decomposed the rational function into simpler parts. Now, if we come back to our equation and read the last part, the task says find the stabilized profit margin, and that is responded to by the last part. The club's financial advisor states that as sales become very large, that is, if x tends to infinity, the long-term profit margin stabilizes. So it means we have to find the limit as x tends to infinity, the limit of the profit margin as x tends to infinity, and that is the value that we need to get. Because even the last statement says, but the advisor did not provide the value of the stabilized margin. So going forward, part B, we need to find a limit of the function of the profit margin as x tends to infinity. And this is equal to a limit as x tends to infinity of this. So we use this, we don't use the other expression, the one before decomposition. So this is 13 over 9 over x plus 1 plus 13 over 9 into x minus 2 plus 20 over 3 into x minus 2 squared. So why do we use this? Because we have control over this value of x, because we know when we have x in the denominator, as the value of x becomes too big, just imagine we have 1 over maybe a million, this value becomes like it tends to 0. It becomes very small that we can approximate it to 0. So this is what will happen to this, and also this. Since we don't have any x in the numerator, but if we have x in the numerator, it is very hard to conclude. Then we need to know the exact values of x. But in this case, since x is only in the denominator, we can, as x becomes too big, we can conclude that this will go to 0, this will also approximately be 0, and this will also be 0. So it means that the marginalized profit will be 0%. Thanks for watching. Don't forget to subscribe, to like, comment, and share this information to anyone who needs it. Goodbye.